Hello guys, in this video tutorial we are going to discuss about the breadth-first traversal and its implementation using Java queue. And you may remember that we were talking about the breadth-first traversal and some of the major characteristics of the graph traversal in our previous lesson. If you haven't watched the video yet, you can go and see the previous video on the graph traversal which I did. Before I start with the breadth-first search traversal implementation, I would like to discuss about some of the data structures, especially the stack queue that we used during our previous implementation. The things I wanted to highlight that some of the questions that the interviewers are asking when we are facing for the interview regarding especially for the data structures. You may remember that we were using stack for the breadth-first search for the breadth-first search traversal during my previous session. So I have opened the implementation of the actual stack class. If you can see here, the stack is a class which is extending the vector class. When you see the vector class, you may remember that vector when we are talking about the vector, the first thing come to our mind is it's a thread safe class. Why we are saying that it's a thread safe class? If you see, most of the method in the vector class are synchronized. Since these methods are synchronized, we can make sure that the components inside the vector object will always be thread safe, because it is not allowing multiple threads to modify the same component at the same time. But at the same time, you might have heard that the vector class is thread safe, but there are some of the drawbacks because of that synchronized feature. It will be performance wise bit of slow. Stack is extending the vector class. Similar characteristics are inheriting from the vector class to stack. So if you see that the method that we used in our previous session, we were using that push, pop, peek. Those are the methods which I used very frequently. These methods also marked as a synchronize. If you see here, in even it is calling add element method in the vector class, and that which is a synchronized class. We can say that stack class also has inherited the features from the vector class. Okay, then let's move to the implementation of queue, which we are going to use today for the breadth-first search traversal. Actually, queue is it's not a class as we saw in the stack, which is a class, but queue is an interface and which is extending the collection framework. And here are the few methods that are in the queue interface. Since it's an interface, we need to find out the implementation when we are doing the breadth-first search traversal coding. So we can see what are the actual implementation class of the queue. So I will just find it here. Let's say I want to use the implementation of the poll methods. There are a number of classes which I implement in the queue interface. Out of this number of classes, today we are going to use the linked list for our breadth-first search traversal implementation. You can see that linked list is implementing list interface, dq interface, and if you go to dq interface, it is ultimately extending the queue interface. Not only linked list, there are many other classes which are inheriting queue interface, such as dq, delay queue, priority queue. We'll be discussing more about these extended classes in our coming tutorials, especially the priority queue, which is highly used in heap data structure, which we are frequently talking about when we are discussing about the data structures. So we'll be touching them in our coming tutorials. Okay guys, now it is the time to move into the breadth-first search traversal implementation. Similar to the previous video, I have created a class breadth-first search traversal, and I have another class which is node having three variables: value, adjacent, list, and visited. If I explain again, the value variable is to keep the actual value of the node. Adjacent list is the list of nodes which are maintained in all the child nodes or adjacent nodes of the particular node. and there's another variable which is visited. In this breadth-first traversal, I am using 8 nodes, and I have given the assignment of the node objects here. If you see here n4, n7, n8, again these are leaf nodes which does not have any child nodes, any adjacent nodes. N6 is there, it has 2 adjacent nodes, and n1 has n2, 5, n7 as adjacent nodes. Let's start with the implementation. So first of all, I'm going to create a static method to start the traversal. So again, I'm highlighting that breadth search traversal today we are going to do with the Java queue data structure. So this is the method signature. I pass in the node which I wanted to start the traversal into this method. Let's create the queue object here. So as we discussed earlier, we need to use the implementation of a queue interface. So today in this session we are going to use the linked list as the implementation. So I'll give a type into this queue as node. So when you come into this method call, as usual we can do the iteration of the adjacent nodes of the node class. So I'll use for each. I'll read it as a n variable, and which is similar to that is breadth first search, depth first search implementation. First thing you want to do is you need to check whether this node is already visited. If it is not visited, what you need to do is you need to insert into the queue. I wanted to again remind you that how the queue is working, which you already aware of that first in first out functionality is there for the queue. When you are inserting number of nodes into this queue, ultimately it will be picking the queues, it will be picking the nodes which were inserted first when we are reading the queue. So the priority is given to the nodes which are inserted first into the queue. Okay, now we have read the node and we have checked whether it is visited or not. If it is not visited, I'm going to add each of the adjacent nodes into this queue. Okay, this is done. So and the next thing that we need to make sure that all these adjacent nodes are visited, and this whatever the child nodes of these nodes has to be visited again. For this, what we need to do is we need to have another loop here to read the queue until it is not empty. So this what this while loop is doing is it will be reading the queue until the end of the queue. So how we are going to read the queue is I'm going to use the method poll to read the queue. This will give you the first element of the queue. Before we come to here, our first node which we need to traverse, we need to insert into the queue as well. So for that I am going to use the queue.add method. So I have already inserted the node into the queue here. Similarly, we can mark this node as visited because once it comes here, once it is reached to this method means it is already visited. So I'll mark in as visited true. Okay, our first node is inserted into the queue here. Then I'll come to this while loop and see whether queue is not empty. Then it will come here and get the first node from the queue, and it will read the adjacent nodes of that queue and insert it into the queue if they are not visited. And another thing that we need to do here, when we are inserting in the queue means they are eligible for the read-in. So what we have to do is we need to set visited into this method also true here. Sorry, it should be n, not the node, the child nodes of that node. Okay guys, this is a implementation of the simple implementation of the breadth-first search traversal using a queue. So now it's the time to test our implementation. I'll be writing the main method, which will call this method, and I'm passing n1 as the iteration. I'll be passing the n1 as a starting node for this traversal. Okay, let's discuss more about the answer once we run the method here. Before run, I wanted to put a print statement here just to identify what are the nodes which are iterated through this traversal. Okay, let's run. Yes, now the code is executed. We can see the result here. These are the order of the node traversal when we are using the breadth-first search traversal. So let's see the result and let's try to understand how it has traversed. Okay, since we are passing the node 1, the first element it's going to read is the number 1 node, and what happened is based on this implementation, it will insert it into the queue, then it will go and iterate through the adjacent leads. While iterating, it is inserting those adjacent nodes into the queue. So the queue is get populated with these 3 child nodes of the node 1. And the next time when it comes to here, the while loop, it is checking whether the queue is empty. The queue is not empty here, it has 4 elements already. It will go and read the first element. But since we already read the element 1, when we call the queue.poll, the first element is already removed from the queue. So we now have 3 elements, 3 child nodes which we inserted in while we are iterating through the child nodes of node 1. So when it comes to here, it has these 3 elements in the queue already. It has 2, 5, 7. It will take the next element. When we read the queue.poll, it will check the first element from the queue. The next first element is number 2. It will read number 2, and when it goes to here, it is not yet visited. It will insert the child nodes of this number 2. If you see here, number 2 has number 4 as a child node. It will insert it into the queue. Then again it will come to the while loop. It will see whether queue is empty or not. If it is not empty, it will get the next first element from the queue. Since we have already retrieved the number 2, the next first element is number 5. It will read the number 5, and similarly it will go into the child nodes of the number 5. It will be number 3, number 6. So similar to the other nodes, it will be move forwarding through the elements of the all of these nodes. Since we read the number 5, next element will be number 7. Number 7 does not have any child nodes, so it will not insert any nodes into the queue. So the next element will be number 4. Number 4 also does not have any child nodes, which is another leaf node, and it will come to number 3. Number 3 has child nodes number 7 and number 8, but number 7 is already visited, so it will not be inserted into the queue as per these checks we have put here. So number 7 will not be inserted, then number 8 will be inserted into the queue, and number 3 is iterated already. Now it will come to number 6. Number 6 has number 7 and number 8 as child node, again similar to number 3, but number 7 and number 8 already visited, so it will not insert any nodes into the queue. Then the last element is number 8. It is going to visit. Number 8 does not have any child nodes, so if you see here in the result, this is the same hierarchy that we are seen in the actual implementation of the breadth search traversal. Hope you guys enjoyed this video, and hope you learned something, especially when you are facing for an interview. I suggest you to go through the implementation of these classes stack, queue, and the DQ linked list prior to face any interview, so you will able to get the understanding of the actual implementation of these classes. Thank you guys watching today's video. Let's meet with another video next time. Thank you very much.